Hello everyone, this is Sanjay from GSATU and today my concept video topic of analog digital electronics is semiconductor materials as preferred as electronic devices. Before directly jumping into the topic, we need to know that the materials are classified into three types: conductors, semiconductors, insulators. Conductors are which will pass the current through it are called as conductors, and insulators are which the current does not flow from the material is called as insulator. Semiconductor is acts as a conductor and as well as an insulator. That's why these are mostly used in the devices. Examples of the conductors are iron, copper, and examples of the insulators are wood, plastic, and examples of semiconductors are silicon and germanium, etc. A semiconductor is a material which has an electrical conductivity value falling between that of conductors such as copper and an insulator such as glass. Its resistivity falls as its temperature rises. Metals behave in the opposite way. Its conducting properties may be altered in useful ways by introducing impurities, doping, into crystal structure. When two differently doped regions exist in the same crystal, a semiconductor junction is created. So these are the properties why the semiconductors are mostly used in the electronic devices. First, energy band. In any material, there are two energy bands: valence band and conduction band. Valence band is the outermost shell that determines the conductivity, and conduction band the band outside the valence shell. The two bands are separated by one energy gap called forbidden gap. The valence band contains the electron. Electrons can move to the conduction band if it have enough energy. When the electron absorbs enough energy to jump from valence band to conduction band, the electron is said to be in excited state. The concept of energy band is particularly important in classifying materials as conductors, semiconductors, and insulators. Here we can see the pictures of the separation bands in the three different types of material, whereas in insulator the band gap is more. That's why there will be no electron jumping from the valence band to the conduction band. And in conductor there is no band gap between the conduction band and valence band, so the ions can move easily from conduction band to valence band. And whereas in semiconductor the band gap is less when compared to the insulator. Semiconductor has a smaller forbidden band gap and requires less energy to move an electron from valence band to conduction band. Therefore, for certain amount of applied voltage, more current will flow in semiconductor than in the insulator. Semiconductor elements. Low electrical conductivity at room temperature. Electrical conductivity increases with temperature. Gap between valence and conduction band is intermediate in size. Semiconduction elements form the basis of solid-state electronic devices. Metalloids such as silicon and germanium are conducting elements whose electrical conductivity increases as temperature increases. A striking property of these elements is that their conductivity increases markedly from doped with small quantities of their elements. Made from materials that have four valence electrons in their outer orbitals, germanium and silicon are the most common. Silicon is preferred due to the ability to withstand heat. A pure semiconductor material such as silicon or germanium has no special properties and will make a poor conductive material. When silicon is doped with phosphorus, it becomes an N-type semiconductor in which electrical current is carried by negatively charged electrons. When silicon is doped with boron, it becomes a P-type semiconductor in which an electrical current is carried by positively charged holes. Joining a P-type semiconductors to an produces an PN which can function as a rectifier. A rectifier is a device that allows current to flow in one direction but not the other. And we know that the semiconductors are classified into two types: intrinsic and extrinsic. Intrinsic, chemically very pure and possess poor conductivity. It has equal numbers of negative carriers electrons and positive carriers holes. Impurities does not affect its electrical behavior. And in intrinsic semiconductor, silicon has four outer shell electrons. Here we can see the diagram forms a lattice structure to share the electrons. And the pure semiconductor with a material without impurity atoms such as silicon and germanium. Extrinsic semiconductor. improved intrinsic semiconductor with a small amount of impurities added by a process known as doping process, which alters the electrical properties of semiconductors and improves its conductivity. Doping is nothing but adding of the impurities to the semiconductor, and which turns it extrinsic. Introducing impurities into semiconductor materials, doping process can control the conductivity. Adding impurities atom into intrinsic semiconductor is equals to the extrinsic semiconductor. The process of adding specific type of atoms to a specific semiconductor favorably alter electrical characters doping. Two types of extrinsic semiconductors, N-type and P-type. When an impurity increases the number of free electrons, the doped semiconductor is negative or N-type. An impurity that reduces the number of electrons causing more holes creates a positive or P-type semiconductor. Doping. Adding impurities to the silicon crystal lattice to increase the number of carriers and a small number of atoms to increase either the number of electrons or holes. Donors, N-type material. Donors. Add atom with 5 valence band electron, example phosphorus, donates an extra electron that can freely travel around, leaves behind a positively charged nucleus. Overall, the crystal is still electrically neutral, called N-type material. N-type material. Diffused impurities with 5 valence electrons are called as donor atoms. As acceptors makes p-type material. Acceptors add atoms with only 3 valence band electrons. Example boron accepts electrons and provides extra plus to freely travel around. Leaves behind a negatively charged nucleus. Overall, the crystal is still electrically neutral, called p-type. Silicon are added to the positive carriers. P-type material. The diffused impurities with 3 valence electrons are called as acceptor atoms. Here we can see the boron impurity is added to the p-type material, where here the silicon is p-type material and boron is the impurity. P-N junction formation. P-N junction is fabricated from single slice of semiconductors, one side doped with acceptor impurities atoms P region, one side doped with donor impurity atoms N region. The interface separating the N and P regions is referred as an metallurgical junction. Here we can see the P-N junction, where p-type silicon is attached with the N-type here, and here we can see the electrons and holes of the energy bands at equilibrium of the valence band and the conduction band. P-N junction as rectifier. Here we can see that there is a rectifier where the p-type and n-type. Here the p-type the majority charge carriers are electrons, and n-type the major charge carriers are holes. And in the junction, when it is connected to the negative terminal, the positive electrons will attach to the negative side and the holes will attach to the positive side. Semiconductor properties. Electron shaken free can concurrent to close generation, creation of an electron and an hole pair is simply a missing electron which leaves an excessive positive charge due to an extra proton. If an electron and an H plus in contact, they annihilate each other. Recombination and electrons holes are carriers because they are charged particles. When they move, they carry current. Therefore, semiconductors can conduct electricity from T and but not much current. Pure silicon has only 1 free electrons per trillion atoms. So I can conclude that the semiconductors are mostly used in electronic devices because of their properties, like mostly it can, because the semiconductors act as conductors and as well as insulators, and semiconductors like silicon withstand the heat, etc. Thank you.